All right, this video is to practice the binomial distribution. So again, I recommend pausing the video, working through this on your own. So here we have 10 free throws, and we'll say the probability of success is 0.7. We make about 0.7 of our free throws. And x, our random variable, will be equal to the number of free throws made. So here we'll assume independent trials. We could think that perhaps these aren't independent, right? If I shoot 10 free throws, let's say I make 9 in a row. Well, I'm probably going to be nervous on that 10th shot because, I want to hit 10 in a row. But let's say I made 5, missed 4. Well, then I don't really care about that last shot because, I already haven't done that well. But let's just assume that they're independent trials. So I would recommend go through and try to answer these questions. So expected value, variance, standard deviation, probability we make exactly 7, at least 9, and no more than 9. Okay, so I'm going to work through this now. So here, n is equal to 10. We're shooting 10 free throws, so 10 trials. We're told the probability of success, p, is 0.7, which means q, which is 1 minus 0.7, would be equal to 0.3. Okay, so expected value is np, and here is 10. Probability of success is 0.7, so we expect to make 7. Right, that makes sense. If my probability of success is 0.7, I shoot 10, it makes sense that I expect to make 7. Variance NPQ, so this will be 10 times 0.7 times 0.3. When I do that, I get 2.1. Standard deviation is always the square root of the variance, so square root of 2.1, which would be 1.45. Okay, let's find the probability that we make 7 exactly. So we want the probability x is equal to 7. All right, well, n choose x, so n here is 10, and we're going to choose 7. And then we have probability of success is 0.7. How many successes do we want? We want 7. Probability of failure is 0.3. And the leftover, so 10 minus 7. So if I rewrite this, it's 10 choose 7 times 0.7 to the 7th times 0.3 cubed. So 7 successes, 3 failures. And this comes out to 0.267. Now I'm interested in the probability I make at least 9. So the probability I make at least 9, so that'd be probability x is greater than or equal to 9. So this would be equal to the probability x is equal to 9 plus the probability x is equal to 10. And if we use our calculators using our formula, this becomes 0.121 plus 0.028, which is 0.149. And then finally, no more than 9. So no more than 9, so we want x less than or equal to 9. But I'm going to use our complement idea. Right, so I want 1 minus the opposite of this. So I'll do 1 minus probability x is bigger than 9. Right, because I could calculate all of these, right? X less than or equal to 9. So I could do x equal to 0, x equal to 1, x equal to 2, all the way up to x equal to 9. Add all of those up. That's a lot of work, and I don't want to do that. So instead, I'm going to flip it around and say, okay, well, I could also do 1 minus the opposite of that, which is 1 minus x greater than 9. Right? I'm taking the less than or equal to sign and making it a greater than sign. So I switch the direction from less than to greater than. And because this had an equal sign, this will not have an equal sign. Well, there's only one possibility that's greater than 9. This is 1 minus probability x is equal to 10. Right? If you have more than 9, then you must have gotten all 10. We already found this in the prior example. Right? We found x equal to 10 was 0.028. So I have 1 minus 0.028 is about 0.97.